Hello, my name is Tyree Johnson, and today we're going to go over Newton's second law of motion. So I'm first going to show you a virtual lab, and this is a ball rolling on a table, and the red arrow represents the amount of force. And so for the control, we're going to have a force of 10 newtons, a mass of 10 kilograms, and we're going to see the acceleration, which is going to be in meters per second squared. So let's start the control. Sorry, I forgot to reset that. Let's start it again. Yeah, so it starts slowly, but the acceleration is at 1 meters per second squared. Reset that. So for this lab, I want you to write your observations whenever I change either the force or mass. You can write it or you can just have it in your head and think about it. But first, let's go ahead and I'm going to increase the force, keeping the mass constant, and we're going to see if that changes our acceleration. Okay, so for this one, as I increase the force, you saw that the red arrow got a little bit bigger. That means the force increased. That's what I did. I increased the force, and I kept the mass constant. And the acceleration, let's observe what happens. So yeah, it's going faster as time goes on. And it's going pretty fast. So I want you to now write your observations for whenever I increase the force. Okay, so here's what I got. Whenever I increased the force, there was an increase in acceleration. And based off of our control, the acceleration was 1, and I increased it to 15. Now the acceleration is 1.5. So the acceleration increased. So now we're going to do number 2. But this time I'm only going to change the mass. So let's go back to the control. And let's increase the mass. And so let's write our observations or think about your observations. Okay, sweet. So now here you can write your observations. Okay, and this is what I got. An increase in mass causes a decrease in acceleration. So here is our control. And let's observe the acceleration. That's at 1. So if we increase the mass, the acceleration is now 0.67. It lowered. So that's the observations y'all should have gotten. And sweet. So the objective today is to understand the relationship between force, mass, and acceleration through calculations. But for this short little video, we're not going to get to the calculations part. We're just going to explore the relationship between force, mass, and acceleration. So this is a little strip of paper. If y'all can write this on your journal or just watch. The thing in the middle is force, and if I keep force constant, let's observe what happens whenever let's increase the mass. So if I increase the mass, we see that the acceleration decreases. And so let's go ahead and confirm that with our little diagram. If we increase the mass, the acceleration decreases, and that corresponds to our diagram. And so if we decrease the mass, we should have an increase in acceleration. Let's go ahead and decrease. And yeah, the acceleration is now 2 meters per second squared. And so that's the relationship I want you to see between force and acceleration. They are directly proportional. So if we increase force, the acceleration is going to increase. And if we decrease force, the acceleration will decrease. And force and mass are indirectly proportional. If we increase the mass, there's a decrease in force, and if we decrease the mass, there's an increase in force. And so now we're able to answer those questions, but for the sake of time, I want to go ahead and explain what Newton's second law is. So Newton's second law is force is equal to mass times acceleration. And so the mass times acceleration will give us force, and we can manipulate that based on the question to find our desired answer, either force, mass, and acceleration. And thank you.